Decomposing and balancing different levels of data flow diagrams. A context level data flow diagram is an overview of an organizational system that shows the system boundaries, external entities, and the major information among the entities and the system. The external entities serve as data sources and/or sinks. Here's a context level data flow diagram. It has a process, the highest level process for all the different data flow diagrams that we're going to talk about today, or charts that we're going to talk about today. It has two entities. This entity is a source and a sink. This entity is a sink. This is a source and a sink because it's the source of data flow X. This is a sink because it's the place where data flow Y goes. Data flow Z is sunk in this sink B. Next, we will decompose this process using a level 0 data flow diagram. A level 0 data flow diagram is a diagram that represents a system's major processes, data flows, and data stores at a high level of detail. In order to go from a context level diagram to a level 0 data flow diagram, we need to do functional decomposition. Functional decomposition is a continual and repeated process of breaking the system down into finer and finer detail, which creates a set of charts in which one process on a given chart is explained and drawn in greater detail on another chart on a lower level. Balancing is the upkeep and maintenance of inputs and outputs to a data flow diagram when that process decomposed into a lower level. Here we have the context level data flow diagram we were just looking at with its source in sink A, its sink B, the actual one process, the very high level process, and the data flow X going in, data flow Y going out, and data flow Z going to sink B. We still have sink A, we still have sink B. This process here has been turned into process T, process U, and process V. Note that this is an abstract representation of data flow diagrams, and so therefore it's not following the rules that you should be very careful that you follow, which is that you name processes with action verbs followed by noun phrases. Data flow X remains in this diagram. Data flow Y remains in this diagram. A and B remain in this diagram. New information is this data store and M&M data flows and data flow A. Let's look at the balancing that's occurring between context level and level 0 between these two diagrams. Source and sink A is on both, sink B is on both, data flow X is on both, data flow Y is on both, data flow Z is on both. This process has been decomposed into three parts, T, U, and V. New symbols have been introduced, data store N, data flow M, data flow N, data flow B, and data flow A. When you put it all together, this is how context level data flow diagram and a level 0 diagram relate. Processes are split up, entities are passed through, data flows are passed through. If there are new processes and if there is a data store, then new data flows need to be inserted. Here's a level 0 data flow diagram, the one we've been looking at. Next, we will decompose this process. We're going to call this a level 2.0 data flow diagram. This is a level 2 data flow diagram. Let's look at it this way. This is a level 2.0 data flow diagram. This is a level 0 data flow diagram. Okay. This is the data flow diagram that we're going to compare to the level 0 data flow diagram. The common things that we're carrying through from 0 to 2.0 are the inflows to 2, which are Y, B, and M and N. We're going to carry the data store down as well. When we do that, we refer to that as balancing. The process that we're going to decompose is 2 into 2.1, 2.2, and 2.3. Because we decompose 2.1, 2.2, and 2.3, we now have new data flows. These data flows will need to be carried to our next level if they're touching the process that we're going to blow up, which is 2.2. Notice that we did not cover this process or this data flow or this process or this data flow on this level 2 diagram because we were only interested in items to explain this process here. And the things that explain this process are the data flows that are going into it, the data store that's related to it, and the items within it. Next, we will decompose process 2.2, process E. We are breaking up process E into 2.2.1, 2.2.2, and 2.2.3. The things that are common that we're carrying through is data store N, data flow M and N, data flow K and H because they went into 2.2. Here they are, K and H, as well as G and C because they come out of 2.2. And here they are, G and C. We are taking this process and breaking it up into 3 pieces, 2.2.1, 2.2.2, and 2.2.3. However, because we now have 3 new processes, we have to have data flows amongst them, and they are brand new symbols, and so they are represented by Q, R, and S here. Things we did not break down to level 2.2 are things related to 2.1 and 2.3. But we did these two, this broken up, these two, and this. Here's the complex chart that shows everything we just talked about. Let's talk about some common errors that students make when they're learning how to do data flow diagrams. You cannot move and put a data flow between a sink or a source and a sink or a source. There needs to be a process in the middle. You cannot simply pass a data flow through a process and have the same name. So an output needs to have a different name than the input. See the Z here? A data store needs an input. This one doesn't have an input. This process has no outputs. Okay? This data flow should not have 2 arrows on it. If you want to represent this, you need to have 2 arrows. One pointing one way, one pointing the other way. This process creates data out of nothing. You can't do that. You need to give this process some data so that it can alter that data and have an outflow. This data store has no output, just like this one had no input. This data flow here is coming directly from an entity or a source, which is not appropriate. You should have a process moving this data. A couple more things I'd like you to remember. Data stores do not create or destroy data, they simply hold data. Processes do not create data out of thin air, they simply manipulate data. They can put data into data stores, they can take data out of data stores in terms of copies, they can update data, and they can change data, but they don't create data. Thank you.